broadcasting live at the moment on February 22nd for CS-030. I'm currently double broadcasting. Today is February 22nd for CS-030. That you can see the background okay?
Yeah, I can see the background.
Great, thanks. Single broadcast. Okay, checking my audio. I've got music playing. Let's pause that audio. That is a song called Up Fronts by a performer called Ketsa, K-E-T-S-A. It is open source music. All right, today we have quite a bit of moves to do. Let's go ahead and run through our checklist to make sure that we are all present in our software while people are still showing up. Getting going a little bit faster than we usually do. I had a little bit more space this morning. All right, so for today, in order to get into class, we have a checklist that we run through. Let's pull that up on screen. Find a quiet location, tell your roommates you're in class, and so they're going to have to put away their slide trombone for the period of class today. Make sure you've got headphones on so that if you do go off mute, you won't echo into endless inception like I like to start my lectures with. Turn off notifications on your phone or computer. I need to do that. You can do that on the Mac by sliding from the right to the left and then sliding down. So you see Do Not Disturb show up, but I also have to make sure that I do this on my phone as well. Otherwise, all the very interesting things that my family are engaged in throughout the day show up during lecture, which I'd rather not have happen until I'm done. Okay, so that's done. Shut down any extra apps or browser tabs that you might have open. So I have to do that by checking on the bottom for me. Everything looks, let's say I don't need Signal, that's communication. I shut down mail because I also don't want that. Music is good for intro, Slack and Discord for emergencies. I don't need my calendar. I don't need my activity monitor. Preview, terminal, the rest I kind of need. Okay. All right, wait for my window manager to pop up. Okay, great. Make sure you've got Canvas open for today. Let me see, we should be published. So we're on class 18 today. We'll look at the calendar in just 1 second. I need to track down where my calendar is. All right. Make sure that you've got Eclipse open and connect to Saros. So I am connected to Saros. Let's see if all is going well. I'm connected to Saros. Let's see. Saros, where you be? Okay, way down there. And I am connected to Saros. So for those of you that are currently online, I'm going to go ahead and share with you, and then we'll come back once we're done with our checklist. That'd be Addie, Ben A, Ethan, Faith, Frank, Landon, and Thomas. All right, and I'll let that happen while we keep going on our checklist. All right, make sure that your VPN is on so audio works. I've got mine working okay. Make sure Firestorm is open. Good. In Firestorm, let's rebake our avatars so we look good. Boom. So if you look on the screen right now, you can kind of see what happens when people don't bake their avatar. They look like floating wigs in some cases. Good morning. Let's just say good morning to everyone here. We'll say good morning in a sec here. Let's finish our checklist. All right, make sure we're at midday. Make sure your draw distance is a low number. Make sure you're in the classroom and make sure you can see your classmates' names. So I'm going to go under World and set my environment to midday so it looks like it's daytime. I can see your name tags. My draw distance is relatively low today. Great. So as I look around the classroom, morning, good morning, Bernie. Good morning, Monty. Good morning, Dodger. Morgan, you're sitting by Dodger. Dodger likes you this morning. Congratulations on being dog's best friend. Landon, good morning. Carson, good morning. Carson saw Dodger this weekend in person as we were walking on campus. My wife and I were walking, so that was kind of fun. It's kind of weird that some of you folks I've never met in person, so that was fun. Although I do see your faces pop up on various sorts of campus communications, so I kind of know what you look like in some cases. Frank, good morning. Ethan B, good morning. Faith, good morning. Looking over here, Addie, good morning. Thomas, good morning. Sam, hat's looking good, everyone. Dee Dee, good morning. Ethan, good morning. Trent, and Josh, good morning. All right, let's see. Let's take a look at the calendar. Let me pull the calendar down for us here. And are we looking at this class? Nope. Let's look at this class. All right, it is Monday, February 22nd. You've got a programming assignment due tonight, which is about making a pyramid in JMonkey Engine. Some good questions over the weekend about getting that up and running. Let me pause for a second and see if there's any questions that you want to ask right now before we get rolling on some more of Chapter 7. Go into in-game for a sec. All right, broadcasting on YouTube, just for the purpose of the recording, what we ran through right there was an example of how to change your zoom distance in JMonkey Engine so that you could accomplish Episteme 6. There are different ways that you can tackle that problem of not being able to see your pyramid. One is to change your zoom distance, or the other one that Josh offered for us was to shrink the size of your pyramid. Both of those are fine. Okay, so let me then open with a prayer. If you would join me for a sec, I'm just a little burdened today by all the many systems that are out there. In our senior seminar class, we talk a lot about the ethics of the computer systems we build, and we're just sort of keenly aware of all of the different ways in which computers are implicated in a lot of the challenges that we're facing. So I'm going to read a prayer. It's a prayer for engaged computer scientists. It is on Canvas. I wrote it, but I wrote it based on um, another prayer, which is kind of a funny prayer because it's a prayer for someone writing code. But I changed it a little bit to address the systems that we are part of. So I'm going to read it. Father, we know there are problems with our systems. We know we can't fix everything that we want to be fixed on this day, but we humbly aim to make it better today. We know that major changes are needed, but we can only make these changes slowly and methodically, or risk the total destruction of that which we depend on. We confess we only want to work on the more interesting parts, but we understand we also must work on the more mundane improvements that affect our neighbors every day. Let us change the code, the law, the markets, the social norms that we can change, and leave that which we cannot, and know the difference between the two. Please let your kingdom be more present tomorrow than it was yesterday. In Jesus' name, amen. All right, thanks. My kids make fun of me because I tear up at everything, and this is no different. Okay, so we're on chapter 7, and we're talking about arrays, and we're talking about the way in which we keep track of lists of elements and different kinds of collections, linear collections of things that we're interested in paying attention to. And what we talked about last time was we talked about the way in which we can declare our arrays, and we talked about ways in which we can use them. We used a lot of square brackets, and I want to carry on with that. And what I want to do is I want to do a couple moves that show us how we can use arrays in slightly different ways that set us up for using the object-oriented method. But we've got a bunch of bits to get through before we do that. So let's take a second and give everyone another chance to get on Eclipse and Saros. Let's see what we've got loaded up. We've got Hello World for class 18. Some of you all managed to make it on. Great. Let me go through and make those who are currently on read only so they don't inadvertently or vertently screw things up. All right. Yeah, I'm also working on our attendance board. I kind of got deep in the weeds on programming OpenSim a little bit and had to pull out to get some other stuff done. All right, so Ben Fernberg, you are being added. Carson, you're being added. Ethan B, you're being added. Faith, we're gonna try and add you. Josh, we're adding you. Monty, here we go. Let me give it a second to let those catch up. All right, Matthew, here you go. Dee Dee. Morgan. Josh, you might want to try restarting Eclipse. Give those a sec to catch up. Matthew, you might want to try restarting Eclipse. And Trent, here's your invite. All right. Looks like some of you connected. All right, now I'm going to go to the top and I'm going to set those new additions to read only. So Ben F, you're switching to read only. Good. Carson, you're going to read only. Ethan, you might want to restart Eclipse. Still working on Carson. Okay, that didn't work. We'll try again in a second. Faith going to read only. Okay, that worked smooth. Monty going to read only. Smooth. Dee going to read only. Let's see, something happened with the invitation. I don't know who this invitation that was, but something broke there. Dee still working on read only. Something happened there. Morgan going to read only. That was smooth. Trent going to read only. Do one more pass of invitations for those of you who tried to restart Eclipse. Carson, here we go. Josh, here we go. Sam and Trent. All right, Trent, something broke again. All right, we'll let those settle out. And we'll switch those that have made it to read only, and then we'll move forward. Dee switching you to read only again or giving it a shot. Yeah, it looks like on my side. Yeah, who's speaking? Okay, let me switch to, hang on one sec. Let me get everyone else set up. All right, looks like everyone's good. Dee, for some reason, my ability to set you to read only is not working very well, so let me just ask you not to edit anything today. Oh no, it looks like you just dropped out for some reason. Okay. Okay, so I acknowledge that not everyone was able to make it. For those of you for whom you were having invitation problems and whom I haven't sat down and worked with you on firewall issues during office hours yet, that would be helpful. Pretty regularly, I find that if I'm able to sit down with folks who are not able to connect and walk through the firewall with them, we're able to fix the problem. We'll do another pass here in a sec if we get a chance, but for now, let's move forward on our discussion of arrays. All right, so I'm going to make a new class for us. Hello World is just to get things going. You should be able to run that without any trouble. To just print Hello World. And I'm going to create a new class called ArrayDemo, and I'm going to create a main method in there, and that should pop up. And in our array demo, I'm just going to real quick create an array type to remind us how we do this. All right, so if I do this and I say int x, that makes one memory location for a primitive type of an integer. Great. If I want to create an array of integers, instead of saying the type int, I put some square brackets after it, and then I give a name to that variable. If I then want to give those variables a name, I can say x equals 5. That would be one integer. Or I can say y equals, and if I do anything here, I can do a literal, right? So if I do the square bracket and I do like 3, 2, 7, 8, that's going to simultaneously, is that actually going to work? That's not going to work for me. I think that has to be done at the moment of declaration. Let's just see if that's true. Yeah, there you go. You can only do that at the moment of declaration. Okay. So if we're not going to initialize at the same time, that would be one thing that we could do. Let's see. One thing that we could do to initialize it would be to just initialize it straight off the bat there. That would set up a location with 4 integers in it. Otherwise, we have to do something that looks like new integer and then how many items we want to put in it. So the first one creates 1 integer, the second one creates 4 integers, and then if we want to populate it, we can use the square brackets as well and say y0 equals 3, for example. Go through each one of the different indices that we have allocated, and we can manually fill it the way we did above if we want. All right, so here we see square brackets used 3 different ways. Once in the type with nothing in between it, once in the initialization when we're creating the memory and we say how much memory we want, and then once when we are setting a value equal to 8 in this case. I guess we could possibly have one more kind of way in which we use it where we do something like this. We say y equals 3. So on the one side, we are evaluating it and we're retrieving something from our array. And then on the left side, we are setting something, we're assigning something to an element in our array. All right, so then the next thing to talk about is the way in which we can use our, oh yeah, go ahead. Go in game. What do you got? All right, so to summarize what we just saw there is the question was, do you need all three steps to create an array? The step of declaring the variable, the step of allocating the memory that's going to store your data, and then actually storing the data. You do need all three. In this code, the example of doing it in 3 steps is here with y as step 1, declaring the variable. Here's where we allocate the memory, step 2, and then here's where step 3, we store the data for y. But as you can see here in Z, we did all 3 steps at once. We declared the variable, we allocated and stored data in it using what we call a literal array. And then on 13, 14, and 15, we gave examples of other kinds of literals. A string literal, Patterson, a double literal, a double literal, which is 3.4, and then 15 actually isn't a literal. CC is being assigned the value of a variable. So that's being copied into CC because it's a primitive. Okay, so let's say we would like to use our array and we would like to put it into a method. So what I'm going to do is create a static method up here, which is just going to be a helper, and we'll say add scores. And what we'll do is we'll say we'll have this return the total of an array of integers, and so we're going to use this as a parameter. Why am I getting an error? I'm going to hover to see what my error is. says must return something of type int. Okay, so we haven't finished yet, so we're not getting that correct yet. We're not getting, Eclipse is not recognizing this as correct code because I'm not done writing it and I'm not done returning an integer. What I'd like add scores to do is to go through each one of the elements of values and to add them up and to return the sum. So like summing in a spreadsheet or something. We know that we can sum these things up because values is an array of ints and there's no other type that can be in there, so we're not going to have any type errors. We know the sum is going to be an integer. We do have a slight concern that this could cause an overflow in the highest number integer that we can represent. So what we'll do is we'll go ahead and create a long variable, which will be total. We'll set that equal to 0 just to initialize it. And that's going to be what we call an aggregator variable. It's going to aggregate the total as we go through a loop. We don't know how many elements are in our values array in line 5 that's being passed in because we're writing this abstractly. We can pass any array we would like into 5 as long as it meets the type requirements, being an array of integers. And we want this to work regardless of how many elements are in there. So we can write a loop, and I'm going to do it with a for loop, and I'm going to declare an integer I in the first section, and I'm going to initialize it to 0. So for int I equals 0, that'll be the first step, run one time. As long as I is less than values.length, so as long as we haven't hit the end of our array, at the end of each loop, I'm going to increment I by 1. This is a real common pattern for going through an array of values. And as we look at each particular index in our values array, I'm going to update total, and I'm going to say total plus equals, that's the same as total equals total plus, but we'll use the shorthand, plus equals, and we're going to increment it and aggregate values sub I. We're going to change the signature so we return a long, and then we're going to return total. And if everything goes good, Eclipse feels good about that. All right, so this is an example of using an array as a parameter. Now let's demonstrate how we would use this. Also, we want this to be static. Okay. We don't want, this is not about object-oriented stuff. This is just a method that we want to be able to call. So here in our main method, let's clean some of this up so that we don't have so much stuff around. So get rid of that. Get rid of that. Allocate the memory, store some data in it. Great. All right, and now what we want to do is we want to call it. And so we will say the answer is going to be equal to calling add scores, and we're going to pass in y. Notice when we pass it in, we pass it just the variable name. We don't pass any square brackets or anything. And add scores, because it is a static method, gets that little italic treatment by Eclipse. If I had passed in the wrong type, for example, I had done something like this, Eclipse would complain at me and tell me that something has gone wrong. So that reminds me that I need to just do y. And then let's just print out the answer. All right, and if all goes well, it'll be 3 plus 2 plus 7. So 5 plus 7 is 12, plus 8 is 20. So it looks like it should be 29. So we'll just put 29 in there at the beginning to remind us of what we're looking for. And we have an error here because I removed the variable. That was the allocation. Let's just make it a literal, store 5 elements instead. All right, and then when we run this, see how we do. You can see that we do get that the sum is 29. So this is using an array as a variable. It's fine to do that. We can, because these are references, we could actually change the contents of value if we want. So we could have another, let's create another one real quick that changes it. Or we'll call this one reset. And what this is going to do is it's going to change all the values to be equal to 0. And it doesn't need to return anything because it's just resetting it. All right, so what reset does is it takes an array in, and regardless of what's present in it, it will set it all to 0. And so if we call these in sequence down here in our main method, if we say, let's add up the scores, and then let's reset y, and then let's add the scores again and print out the scores, we expect that it would be equal to 0 the second time around. So line 28, we declare our variable answer to be of type long. We initialize it with the result of whatever add scores returns passed in the array y, print it out. We call 30, we reset y. Y is a reference, and so if we make changes in reset, they stick around. And 31, we get a new copy of what add scores is. It replaces what was previously in answer. Answer is already declared, so we don't need to redeclare it. And then we print out what the new answer is, and we expect it to be 0. And if all goes well, when we run that, we'll see a combination of numbers. And on screen, it looks like you can just barely make out that it's 29 and 0, which looks good. All right, let me pause for a second, see if you've got any questions about how we use arrays as methods. All right. Just as another, no, that's fine. Okay, I think that's okay. All right. Let's see, I'm setting up the next move. Okay, so the next move that we're going to do is we're going to work with arrays, and we're going to work with a partially filled array. During class last time, someone raised the observation that one of the problems that we run into with the primitive style of arrays, which is the kind of array that we are working with right now, is that when you allocate the memory for that array, you have to allocate a certain chunk of memory. And if you ever need more memory than that, then it's too bad you don't have it, because you allocate it at one time and then you've got it available to you. So a real common pattern when using primitive arrays like this is to allocate more memory than you're going to need and use a companion variable to keep track of how much data is actually in it. All right, so let's create a new class actually, so that we don't. Let's see. What I'm going to do is I'm going to copy this so that we have that as a reference if you want to study it later. And we'll call it partially filled array. All right, so going over to partially filled array, I'm not sure we're going to need all these. I just want to create some. All right, so let's create a final constant called length in our class here, and it'll be static. And we'll make it equal to, say, 100. We expect that 100 is going to be much larger than anything that we're going to need to work with. And so we'll use that as our maximum size. In fact, let's change it to reflect that. Let's call it max length. And then when we declare our variable here, we can leave that in. We're going to declare it as being max length. Now, we don't necessarily need the whole thing at any given time. So what we'll also do is we'll also create a variable called current length. And current length will be how much data is actually in our array. So we'll think of, maybe let's clean this up a little bit. Let's just make it so it's one line. All right, so when we start, y has got nothing in it. Our current length is 0. That's not how much could be in y, it's how much we're currently keeping track of. Is current length the right thing to say? I'm trying to think about if the name is appropriate. Actually, let's change this here, because the length is the length. Let's call it max capacity. I'm trying to use words that are appropriate for what we're doing, and we'll say current capacity. No, it's not the current capacity, it's the current size. Let's call it current size. All right, capacity is capacity. Okay, so then what we might want to do is we might want to say, okay, let's partially use this. And let's partially use this by having the user input some data. All right, so for the user going to input some data from the console, we're going to need a scanner. So let's create a scanner. All right, we'll use this format so that when we are done with that try block, scanner will automatically be closed and we don't have to do anything. We need to import scanner, so I'm going to do my quick fix and import scanner for me. And what we'll do is we'll allow, let's say we'll prompt the user. We'll say, hey user, yo user, please enter some doubles. And then we'll continue and we'll say while we've got some doubles. Now notice what we're doing here. We're using something that a method that I don't think we've used in class yet. This is what's called a peek method or a look ahead method. And what it's going to do is it is a Boolean method. So it returns true or false. And what it's going to do is it's going to look at what the user has typed in. And if what the user has typed in will correctly parse as a double, meaning they've typed in characters that we can convert from characters to a double representation. We can take those, that one, that zero, that point, that minus, however we want to represent that double when we're typing. If the computer can correctly cast that to a double, turn it into a number, then this will return true. So if at some point the user types in something other than a double, it will not be true and will kick out of our loop. So we'll communicate that to the user. Well, please enter some doubles and we'll say Q to quit. Although in fact, anything other than a double is going to quit the system. All right, so while it does have another double, we're going to check to make sure we haven't maxed out our array. So we're going to say as long as our current size is less than the length of our array. So there are two things we could do here. We could either say as long as it's less than max capacity, or we could just be a little bit more abstract and say as long as it's less than the maximum size, which we know is going to be length. That's going to cover us no matter how we initialized it. We have to think less if we say y.length. So as long as how much we are using is less than the max that we could use, we're going to go ahead and we're going to put something in it. We'll say that the variable, the data that we're reading in will go into the current size location. So it starts at 0. So our first element will go into position 0. And what we'll do is we'll grab the element that the user has typed in, which we know is not going to fail because we have it guarded by line 15. Line 15 tells us that a double is available. So line 17 will not fail because we've already been told that there is a double available. We'll store it in, not values, in y. Y is a bad name. Let's give it a better name. Let's call it data. All right. See what I did there? I did a trick in Eclipse, which is refactor. And as I was typing it, it automatically retyped all the instances of that variable name. The slow way to do it is to right-click, refactor, rename, and that'll rename all instances of the variable at one time. I used the hotkey in order to do it quickly. All right, so in.nextDouble should not be failing. It's giving me an error. I'm not quite sure why, but I'll get to that in a second. After I put data into that location, I want to bump up the current size so I know where the next bit of data is going to go. So I'll go ahead and increment current size by 1. And then we'll get to the end. Let's see what Eclipse is telling me about that. It's saying, cannot convert from double to int. Oh, that's because this is an array of integers according to my declaration on line 10. Let's fix that. Let's make this all doubles. All right, current size doesn't change because current size is an index, and indices are always integers. All right, that looks good. So we read in a bunch of stuff. What are we going to do with it? Why don't we sum it up? So let me go back to array demo that we had before. Let me grab our add scores. Oh, and you know what? I'll show you how you can use it from here. We'll just say, okay, we'll say system.out. Oh no, that's not going to work because array demo expects integers and we have doubles. So we'll rewrite this in our partially filled array. Plot it up here and we'll say double. Again, we could have a problem with overflow. Won't happen in this case because the numbers aren't enough of them. All right, so add scores is going to take in as a variable values. We're going to have an aggregator variable called total. We're going to go over all of the indices of value, not the contents, but the indices. As we step through each index, we're going to increase the total aggregator variable by the contents of that particular position here. Then we'll return the total. So come down here, we can say system.out.println, and we'll say the total is add scores data. All right, let's run that and see if it works as expected. All right, please enter some doubles. Good, let me give us a little bit more space to see. I'm gonna type in here, let's type in 10 and 20 and 30, so the sum should be 60, and then I'll hit Q, and we get the total is 60. So real nice user interface. One thing we don't have though is if we do hit max capacity, we're not sure what's gonna happen. So let's work through that logic. Let's make our max capacity be just 3. So that if someone types in 4 things, it's not gonna work out. All right, so we don't have to change any of our code because we used this constant instead of a magic number. And so none of our code needs to change except for line 7, which is kind of nice. But we do have this case on line 24 that if we do max out the amount of data that we have, it just fails silently. Because 24 will find that current size is not less than data.length, and so we won't store the data, and we'll just go to line 28, and we'll go back to line 23. Oops, did I drop my session? Oh, shoot, man. Let me kick out of YouTube for a second to debug. All right, so we've got a second integer, which is not values.length, not data.length, but is the current size. So we're keeping a separate variable that's keeping track of how big our particular array is. And that's so that we can allocate a certain amount of space for our array. We only get to allocate it one time when we're using a primitive array. And so we want to have this other variable, which is how much we're actually using in that current array at any given time. So that's what current size is. So what we've done here is we've seen an example. What I've typed in is some code that is an example of reading in values from the user. And as we read in values from the user, we store them in the array and we increase current size, which is how many things are currently present in our array. We're about to do a little fix because if we run out of space for whatever reason, then the user doesn't find out and it just looks like it fails silently, which is sort of bad programming. All right, so what I'm going to do is on line 24, I'm going to add an alternative to the if statement. So if it turns out that we have run out of space, then I'm just going to have an else that says, system dot, I'll use a slightly different print stream, which is called .err instead of out, which we haven't encountered yet. And I'll say, there is no more space. All right, and it won't crash. It's just going to print out that there's an error, and if the user continues to enter stuff in, then just no data is going to be collected. And so if we run that now, and remember our max capacity is, what is it at? It is at 3. So now if we run this, go to our console, please enter some doubles. So now I'm going to enter 10 and 20 and 30 and 40. Oh, I got an error. The never ending, there is no more space. Okay, so that's actually not a really good result either. It's just writing no, there is no more space forever. It appears to be in an infinite loop. It's still running because I've got my red square there. So I'm going to stop it and go debug why is there an infinite loop. I happen to know why there's an infinite loop. I didn't notice it at the time. What's happening is on line 22, I'm creating my scanner. On line 23, I'm checking to see if the user has typed in a double. If they have, then I'm checking to see if we have space on 24. We don't have space, so we go to 28. We output that there's a problem. We then go to 30 and 31, and we go back to 23, and there's still a double there. We haven't actually consumed the double from the scanner. We haven't run that double across the checkout line, across the checkout scanner. We know that there's one coming, but we haven't actually consumed it. We just keep saying there's one ready to be scanned on line 23 over and over again, and we keep printing out there's no more space. So what we can do here is we can just do in.nextDouble, which is going to scan in the next double. It's going to consume it, but it's not going to do anything with it. But we've at least alerted the user that that's what's happening. So let's go ahead and run that. Let's try that again. Now we type in 10, and you can't really see that. Let me up that. So we type in 10 and 20 and 30. Okay, that's the last one we had space for. Now we type in 40. There's no more space. All right, well, darn it, I want more space. I'm going to type in 40 again. No, really, there's no more space. Oh, yeah? Well, what if I type in 50? No, still no more space. What if I type in minus 10? Still no more space. Okay, what am I going to do? Well, I said Q to quit, so I'm going to hit Q to quit. And now I get the total is 60. The total at 60 is of the elements that we have typed in for which there was space. So 10, 20, and 30 add up to 60. So that was a much better user experience. It's still command line. It's not like JMonkey Engine or anything, but it's still a lot better because at least we're providing some clarity on what's happening. Yeah. Okay. Questions about that and how we use current size in order to keep track of how much data is currently in an array. This idea that we have an array that is bigger than what we need, has more capacity, and we're going to use current size to indicate how much is in there. I mean, maybe as an analogy, you could think of like the Westmont shuttle or a public bus that has a lot of seats in it, and that would be the max capacity. But the number of people that are currently sitting in the seats, the number of passengers that you actually have, that's analogous to current size. So maybe the Westmont shuttle can hold what's it, like 2 times maybe 10, maybe 25 people. I'm not sure. I'm guessing 25. So max capacity would be 25. If there are no passengers in it, there's currently 0. One person gets on board, and now current size is 1. And there's an interesting dynamic here because of the 0 indexing. When there is one person in the when there's one piece of data in our array, the next element actually goes in data current size. Because although there's one currently there, we know that one is actually the second position. So when it comes time to put something into our array, we put it in data sub 1, even though, because data sub 0 has that one bit of data. And then we increment current size plus plus. So there's a subtle interaction here between 0 indexing and the way that we're using current size. And we're doing it very carefully. Current size is how many pieces of data are in our array, and it's also the index where the next piece of data will go when we place it in our array. So there's a subtle thing happening there. This idea of having a higher capacity and having a current size, which is keeping track of how many things are actually present, is a key underlying concept that we need in order to move into our idea of an array list. All right, so we'll keep that in mind as we move forward. So partially filled arrays. There's some good graphics in the book about this, but I want to move forward here. Let's see. Oh no, I made a mistake here. Actually, there's a mistake in this code. Shoot. Okay, so here's the, does anyone see the mistake? It's on screen. I'll give you a second to see if you can see the bug. Okay, so here it is. All this big talk I just had about the array having a capacity and us only paying attention to the amount of data that's currently in our array, I totally threw that out the window when I calculated add scores. So down in line 34, when we called add scores, we passed in the array, and up on line 10, we just added all the data that was in our array regardless of the capacity. So that's a mistake. We only want to add up the elements of data that are in our array that matter. So we're going to have to change add scores so we send it the array and our current capacity. So we'll send it current size. And then up here in add scores, we need to change this to be, I'm going to sneeze, excuse me, I'm going to sneeze. Wow, bugs. I'm allergic to bugs, so I sneeze. It's just what happens when you're a programmer like me. It just becomes part of your biology. All right, so integer, we got current size. So we're going to take that in, and instead of adding up everything values.length, we're only going to go up to but not including current size. Oh, what a disaster. That's embarrassing. All right, the whole point of this was to only use the current size, not to use the full capacity. So, the difference is we might have a bunch of garbage in our array because we've been using it, maybe deleting elements. If there's something other than 0 in the extra capacity of our values, we would have gotten a bunch of bad answers. Now, the reason why it worked out okay is because what was in that extra capacity was zeros. But if something other than zeros had been there, we would have gotten totally the wrong answer. So big, huge bug. Ugh. That's why you need to write tests, to be honest, so you catch bugs like that. All right, any questions about why that bug was present? Any questions about current size so far? All right. Then here we're going to make another move then. We're going to make another move in order to talk about the way in which we can have arrays filled with objects instead of arrays full of data. So let's make another class to show you another move. We'll call this justify objects. Make a case for why we need objects. All right, so let's say that we are going to have a bank account and we're going to have a lot of them. And so we want to keep track of everyone in our bank account. So let's make the number of people that we could possibly have. We'll call it max customers. We'll set that equal to maybe 100. Make sure that compiles okay. Great. Now let's make an array of account numbers. And we'll say an account number is going to be maybe an integer. We'll say integer. It's a local variable, integer. We'll call it account numbers. We'll set it equal to an integer array. It's going to be a new integer array. We can have up to max customers. Get that. Great. And what else do we need? We actually need to know how many actual customers we have. And right now we have 0. And so now we have a bank. Great. So we have a bank, we have some account numbers, we have some actual customers. But a bank account also needs a balance. So here's the justification for the move. We also want to keep track of the balance that's present within these accounts. So now we know that we don't want to use doubles to keep track of money, but for the time being, just to make my point, I will create an array. Oops, this is an array of account numbers, and this is going to be an array of balances. And it's going to be a new array of doubles. And just like the other one, it's going to have max customers. All right, and I don't need a separate I don't need a separate actual customers to keep track of how many we've got because we're always going to have one account number and one balance for each of them. So this is what's called a parallel array. And so what we might do is we might add a new customer to our system, and we might say, for example, account numbers sub actual customers, which is our next one. We'll say the account number is maybe 1,000. We'll start with account 1,000 for some reason, and then we'll give them a balance, and they'll start out with 0. And then now that we have one customer, we'll increment our actual customers. Great. All right, now let's add a second customer. And we'll make them customer 1001. And then for balances, we'll let them start with 10 bucks. And then we'll increment actual customers. Now let's say we would like to print out these customers in an array. So let's say we'll use an int loop while int equals 0, int I equals 0 while I is less than, I guess actual customers. Make sure we don't make that same mistake we did before, I++. And we'll say system.out.println. We'll do print. We'll say account numbers sub I. Print that out. Okay, we did print instead of println, so it's going to be on the same line. And so on the same line, we're going to then say amount, and we'll do balances. I will be incremented. Everything looks okay to me. Anyone notice any bugs? I don't see any bugs. Shout out if you see any. Then I'm going to run this. All right, looking down on the console, which you can't see right now, but the console shows everything is fine. Let me make sure I'm broadcasting console. All right, that looks good, but architecturally, this is a bad choice. And the reason why this is a bad choice is because we have what's called parallel arrays here. And what a parallel array is it means that we've got two different arrays that have to have the same number of elements in them each time. Every time you have an account number, you've got to have a balance. And if you increment one, you need to increment the other. And so this is a bad architectural decision because now you're keeping track of two arrays at once. So let me show you the better move. And what I'm going to do to show you the better move is I'm going to copy this. And I'm going to paste it. And we'll call it justify objects 2. And what we know is we need an account number and a balance in each one of these. And what we're going to do in order to make them not be separate arrays is we're going to create a class that's going to help us out. So I'm going to create a new class and we'll call it bank account. And it's not going to have a main method. It's just going to be something that we use. I'm going to open that up and our bank account will have an account number and it will have a balance. And those will be private. And I'm going to use the source helper to create some getters and setters for me. And I don't want to be able to set the balance. I just want to be able to get them. So there's some code that will create getters and setters for me. And then I also want a constructor. And I want the constructor to use those fields. I want it to be public. Boom. Okay, so Eclipse wrote some code for me. So now I've got a class with setters, and you initialize them by calling the constructor. Real basic class, perfect for this instance. And now when I go to justify objects 2, the new beginning, Instead of creating an array of integers and an array of doubles, what I'm going to do is I'm going to create an array of bank accounts. And now I can get rid of these dual competing arrays, and I still have to, keep track of actual customers because I've got an array. But what I can do here is I can say accounts sub 0, sorry, let's come down here. Accounts sub actual customers is going to be a new bank account with 1,000 ID, or it's going to be account number 1,000 and a balance of 0. And we'll increment account number, that's plural. And we'll do the same thing here, but it's 1,001 and $10 instead. Down here, we need to use the getter. So we'll say accounts sub 0 dot get account number. And down here, it's got to be accounts sub I dot get balance. All right, so if we run this version of just where we are justifying the objects, when we run that class, we can see that we get the same result, but this is much cleaner because we only have one array. That array is accounts. It has objects in it instead of just a simple primitive value. And then we access them as get account and get balance. But what's key about this is that it's all being forced to be kept together. It would be impossible for us to have a bank account that doesn't have both an account and a balance. Whereas if we go back to our original one, because we had two separate arrays here, it would be possible for us to have an array of account numbers where the number of account numbers is different than the number of balances. Like they can get out of sync. The architecture isn't supporting our mental model of what we want here, which is a one-to-one correspondence. And so that's why we build out this separate kind of way of creating an array of objects instead of parallel arrays. All right, I don't want to over talk about that, but that's what we got. Questions about that? Any questions about the parallel architecture? Okay, no questions. Single broadcast YouTube. All right. Now that we have arrays, I'm going to introduce a fourth kind of loop that we had. Up till now, we've had a sequence of loops that included a for loop, a while loop, and a do loop. And now I want to introduce the enhanced for loop. It is very much like what I've got here on line 18, but we're going to clean it up a little bit and avoid some of the housekeeping that's necessary. So just like we can have for int I equals 0, I equals actual customers, so on and so forth, we can do this move here. We can say we want a bank account I, and that's going to range over each of the elements of accounts, and we're going to create a loop of those. Instead of doing system out and accessing the account directly, we are going to here. Let's change that. Let's call it current account. All right, so this right here is fast enumeration, or the book calls it the enhanced for loop. And how do we read this? Okay, we read this as, first of all, notice the colon. The colon is key. Notice that we're creating a variable, and the variable's type is bank account, and the variable's name is current account. So we are creating a new variable, bank account class, and the variable is current account. This colon is like a range that we're giving it. We're saying range over all of the bank account objects that are in the array accounts. So we know that accounts has several different bank accounts in its array. And this loop is one by one going to go through each one of those accounts. And it's going to set the variable current account equal to position 0, then position 1, and so on and so forth, all the way up to the maximum number of accounts that we have. All right, so now this is helpful in that it is going through all the elements of accounts, but it's not helpful because it's not respecting our actual customers loop. So we've got kind of two things at play here. This is equivalent to saying, so while fast enumeration is helpful for going through all the elements of an array, it's not helpful for what we want exactly here, which is to go through just a certain number. So let's just put that out. All right, so this doesn't build very well, right? Like this is a bad story I'm telling. I'm telling you a story about a way in which you can create an array that has a lot of capacity and then keep track of how much it's got, much like a water level or the number of passengers in a bus. And now I'm introducing this kind of fast enumeration that doesn't respect that at all. And these are just two concepts, and we're going to need both of those concepts moving forward, but they don't really build on each other exactly. Like they don't dovetail really nicely. They're two separate ideas, but they're in the same space, and so we need both of them to move forward. Um, Mainly, what I'm showing you in line 26 is the syntax for how to accomplish this. All right, man, oh man. Okay. All right. Well, that's just where we're going to stop for today. There is much to cover about arrays. And we're going to get there. But okay, so we did a bunch of moves today. Uh, we looked at a new kind of loop moving backwards. We looked at the way in which you can take parallel arrays and merge them into one array of objects. And then before that, we looked at capacities, changing capacities independent, changing actual capacities different than max capacities. And then that was all based on the idea of the array. So a lot of different moving components here building up to how we are going to implement a more robust version of this in an object-oriented manner. All right, that's all I've got for today. We are out of time. Um, I'm going to stick around here and oh, before you go, let me grab an attendance list because I don't have my attendance board yet. Stand by, stand by. All right, got it. All right, so thank you for your attention. Try some of this code out on your own. If you stick around, I will try and share again with those. Okay, and that ends the broadcast on February 22nd. And let's go out with Kitsa and up fronts.